Hello, geometry folks. Welcome to 7.2. So we're still talking about this idea of circles. And here we're going to talk about measuring angles and arcs and kind of what those are and how those work. So let's kind of look at what we're dealing with here. So a central angle literally just means that the vertex of the circle vertex of the angle, rather, is the center of the circle. That's literally all it means. So here, angle ABC is central. All right, now the sum of central angles, as you might expect, a circle is 360 degrees. So then the sum of the central angles, so angle 1, angle 2, angle 3, is also going to be 360 degrees. Okay, so that's kind of all you're looking at. So all of them together. If I have, if I was going to add one and 2, that would be something different. But if I'm adding all 3, they all have to add up to 360 degrees. Now, sorry, I jumped ahead here. So now, if you look, how do I find a missing value? So I would take, 145 plus 165 plus x equals 360. And then from here, it's a matter of doing a little calculator mashing or doing a little mental math. So that's going to be 310. So 360 minus 310 should be 50. So x is going to be 50 degrees. Over here, recall that is going to be 90 degrees. So 90 plus 40 plus 85 plus x equals 360. So 90 and 40 is 130 plus 85 360 minus that. So that becomes 215, actually. So that's my answer, 145. So a little bit bigger than 90. Okay. So a couple different vocab terms for you to be familiar with. A minor arc is going to be the short distance. A major arc is going to be the long way around. And a semicircle is exactly halfway of a circle. Okay, this is exactly half of a circumference. Circumference, if you recall, was from last section. That's basically just your distance around the circle. Okay, so you have a minor arc, which is small. You have a major arc, which is large. Then you have a semicircle, which is exactly halfway in between. Okay, so minor is small, major is big, semicircle is halfway in between. So when if I look at GH is here. Even though that angle is 122 degrees, which you might think is kind of big, it's still going to be a minor arc. That's still going to be a minor arc, okay, because it's going to be less than 180 degrees. All right? So now, GLH, that's definitely going to be a major arc. Okay, that's kind of the long way around to things. And GLJ, that is going to be your semicircle. Because it's equal to exactly half the circle, and it's equal to 180 degrees. So now here's where you have to do a little problem solving. A little bit of mixing and matching. So now here's what I know. This is 63, that's going to be 90 degrees. So now, let's see what they're asking. So AED is that. So that's fairly straightforward. Add 63 and 90, so it's 153 degrees. Now, ADB is a long way around, because you go A to D to B. How far around is that? Okay, so here's what I'm going to look at. I'm going to look at the fact that B to E is a diameter. That makes this whole thing 180 degrees. And I'm going to look at this as 63 degrees. So this is going to be 180 plus 63. That's going to be my answer. Now, could I do it a different way? Absolutely. I can absolutely do this a different way. Okay, you know that this is 63. You know this is 90. These make a line. Okay, these are vertical, so that's 63. Okay, vertical angles don't go away. So then, this becomes 27. So I could add all those up together. Okay, I could easily add those all up together. Or I can recognize that what is a semicircle based on what a diameter is, and then go from there to help me out. And again, all I did to figure out those angles was stuff I'd learned from like way back when, Unit 1, Unit 2 stuff, where you go vertical, and then, you know, all the angles in a line have to add up to 180. So if I go from A to B to D, okay, we just figured out that that's 90. We figured out that that's 27. I know that this is going to be 180. So then I just have to add on the 27. There's my answer. Okay, once you start recognizing that, hey, exactly half is 180, figure out what you can add on, then you're good. So here's an idea to know. Minor arcs are congruent if and only if their central angles are congruent. Okay, so that means it kind of works forwards and backwards. If I can say angle 1 is congruent to angle 2, then I can say arc FG is congruent to JH. Likewise, I can flip it around. I can say if FG, if that arc is congruent to JH, then I can say angle 1 congruent to angle 2. So if and only if, you remember way back when from the logic unit, it just means you can flip it forwards and backwards and still be fine. Okay, so here, I'm going to use this graph, but you notice how it's all percentages? I'm going to take that percentage and multiply it by 360. Where did I get 360? All circles have to add up to 360, okay, by definition. So CD is right here. CD is looking at just volleyball. Okay, so now I want 18% or 18.18 times 360. So that's going to be 64.8 degrees. All right, BC is track and field, okay, TNF. That's also going to be 18%. So that's also going to be 64.8 degrees. Okay, last one, EF, that's E to F, that's soccer. So that's 14%. So I'm going to do is take 0.14 times 360. And do a little calculator mashing, you get that as 50.4 degrees. All I'm doing is just taking my percentage as a decimal times 360. Okay, now we're talking about arc lengths. Arc lengths, you're actually talking about a length. You're trying to figure out a distance. If I go from here to here, how far did I walk? Okay, how far did I go? So, and here's all you're doing. It's equal to the ratio of the degree measure of the arc to 360. Okay? So all that means, what does that mean? Okay, the ratio of a length of an arc L to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. So basically all this says is that you take your central angle, multiply it by 360, and you're going to multiply that by the circumference. So you're going to multiply that times 2 pi r. That's all you're doing. Figure out your circumference, take your percentage out of 360. So when I look, zy here would be equal to 75 over 360 times 2 pi 4. So calculator mashing later, 8 pi times 75 divided by 360 is going to be 5.236. And that's a perfectly acceptable answer. That's how far it is. For letter B, for zy, well, you're going to want 130 degrees over 360 times, and then this whole thing is 10, so I can just take 10 times pi. So 130 divided by 360 times 10 pi nets you 11.345 centimeters. And that's all it is. That's how far it is to go from there to there. And that's it. A couple more examples here quick. So A to B, so you go 80 over 360 here times, not equals, 14 pi. So 14 pi times 80 over 360. So you're going to get 9.774. That's your answer. Here for number 8, you're trying to figure out dA. So I'm calling this the radius. So I'll take 40 over 360 times 4.5 times 2 times pi. So a little bit of multiplication. And I get that to be 3.14159. This one is, I don't know if you recognize it, but it's just pi. That's your length. That's your measure. Interesting. Okay, so now you're working on your 7.2 work and these 7.2 quizzes. Okay, I look forward to hearing from you. Thank you.